Next problem. Find P and Q if the following equation represents a pair of perpendicular lines 6x square plus 5xy minus py square plus 7x plus qy minus 5 equal to 0. Given equation 6x square plus 5xy minus py square plus 7x plus qy minus 5 equal to 0, that is equation number 1. So which is representing a pair of perpendicular straight lines, right? That is what they have given. So value of a, we know general formula ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So we are comparing the coefficients. A is equal to 6, 2h is equal to 5, therefore h is equal to 5 by 2, and b is equal to minus p, and 2g is equal to 7, therefore g is equal to 7 by 2, and 2f is equal to q, and f is equal to q by 2, and c is equal to minus 5, right? That is set of equations, that is 2, right? To find p, so we know the condition for pair of perpendicular lines. So if two lines are perpendicular, then a plus b equal to 0, right? So we know that condition, so we are going to use that condition to find p. Now here a is equal to 6 and b is equal to minus p. Substituting that value, 6 minus p equal to 0. So therefore p is equal to 6. You can write it directly because we know the perpendicular line should be 6x square plus 5xy minus 6y square, definitely, right? From that pair itself you can write it directly. So we are just deriving that, right, for that. So therefore p is equal to q. Now to find q, so 1 implies substituting the value of p in the equation number 1, we will get 6x square plus 5xy minus 6y square plus 7x plus qy minus 5 equal to 0. We know condition for pair of straight line. What is that condition? ABC plus 2hgf minus f square a minus h square c minus g square b equal to 0, or in the determinant form, right? That is equal to 0. So we are using that condition ABC plus 2hgf minus f square a minus h square c minus g square b equal to 0. Substituting the value of ABC, so we will get 6 into minus 6 into minus 5 ABC plus 2 into h 5 by 2 g 7 by 2 and f q by 2 minus f square q by 2 square into a 6 minus h square 5 by 2 square into c minus 5 minus g square 7 by 2 square into b minus 6 equal to 0. So simplifying, we are taking LCM as 4. So numerator 4 into 180 plus 35q minus 6q square plus 125 plus 294 equal to 0. Just to do the cross multiplication, we will get 4 into 180 plus 35q minus 6q square plus 125 plus 294 equal to 0. So this implies 1139 plus 35q minus 6q square equal to 0. Rewriting this equation, so you will get quadratic in q, 6q square minus 35q minus 1139 equal to 0. We know solution for the quadratic equation using the formula ax square plus bx plus c equal to 0 means x is equal to minus b plus or minus b square minus 4ac by 2a, right? We are using that formula to find the value of q. So a is equal to 6, b is equal to minus 35 and q is equal to minus 1139. So q is equal to minus b, right, minus 35 plus or minus b square 35 square plus 4 into a into c, that is 27339, right, divided by 2 into 6, right? So we will get 35 plus or minus root of 28561 by 12. So root of 28561 equal to 169. So we will get two values for q, that is 35 plus 139 by 12. Another one is 35 minus 169, right? 35 plus 169 by 12 one value, or 35 minus 169 by 12. So q is equal to 17 or minus 67 by 6. That's all, right? Next, for what value of k does the equation 12x square plus 2kxy plus 2y square plus 11x minus 5y plus 2 equal to 0 represent two straight lines? That is pair of lines, right? That is why they have mentioned two straight lines. We know the condition if ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of straight line, means the condition is abc plus 2fghy, right? That condition we know, so it should satisfy that condition, minus f square a minus h square c minus g square b equal to 0. Here given equation is 12x square plus 2kxy plus 2y square plus 11x minus 5y plus 2 equal to 0. So a is equal to 12, right? Comparing that equation, so from 1 we will get a is equal to 12, 2k is equal to 2h is equal to 2k, therefore h is equal to k, and b is equal to 2, 2g is equal to 11, that implies g is equal to 11 by 2, and 2f is equal to minus 5, f is equal to minus 5 by 2, and c is equal to 2. Substituting that value in the condition, you will get 12 into 2 into 2 abc plus 2h 2k into gf 11 by 2 into minus 5 by 2 minus f square a minus 5 by 2 square into 12 minus h square c k square into 2 minus g square b minus 11 by 2 square into 2 is equal to 0. So after simplification, 2 is the LCM. Numerator 96 minus 55k minus 150 minus 4k square minus 121 equal to 0. Just to do the cross multiplication, 2 into 0 0, so we will get minus 55k minus 4k square minus 175. Multiplying with minus and rewriting, you will get a quadratic in k, 4k square plus 55k plus 175 equal to 0. Again we are using the same formula, right? We know the quadratic equation formula from theory of equation, right? So k is equal to minus b plus r minus b square minus 4ac by 2a. Here a is equal to 4, b is equal to 55, and c is equal to 175. So we will get minus 55 plus plus or minus root of 55 square minus 4 into 175 by 2 into 4, right? So that is equal to minus 55 plus or minus root 225 by 8. That is minus 55 minus 15 by 8 or minus 55 plus 15 by 8, right? So we will get two values, right? Minus 70 by 8 or minus 40 by 8, right? After simplification we will get minus 5, right? 35 by 4 minus 35 by 4 or minus 5, that is the value, right? Thanks.